Okay guys, welcome back. I hope you're enjoying this series, and here's where we left off. We were able to pixelate our original image, turn it into something that looks like Lego blocks. We don't have the right palette yet, but we were able to achieve our first step of blockifying this thing, if you want to call it that. And before we continue, I know this is kind of a beginner project for a lot of people that are just starting learning Python, so we've really got to do some best practices here. And the first thing we're going to do is we're going to take this code that we wrote in main, and we don't want to write this loose every time. We're going to want to reuse this code, obviously. So we're going to create our first function in our program. And let's give it the name Pixelate. That sounds like a good name. So we're going to call this function Pixelate. You do that by using the def keyword, giving your function a name. And then let's think about what we would want to pass into this function Pixelate and what it's going to give us back. So the first thing we're going to want to probably put in is this image path. So we're going to say, here's the image that I want to pixelate. So let's create a image path variable. And the second thing we're going to want to give it is a ratio. We're going to want to tell it how much to scale this thing down and pixelate it for me. So let's call this our scale ratio. And let's set this to a default value. We can do that by using the equal sign inside of the function declaration here. Now, one thing to be careful is if we're going to create a default value here, everything after it also needs a default value. So for example, I could not say, and let's just say our default value is 0.05, which is what I used before. You could set this to something else if you want. If I were to add another argument, and I called this, another argument, whatever, and I didn't give it a default value, this is going to have a problem. It's going to give me an error. So all your arguments that take a default value need to be at the end. You cannot have ones after that do not have a default value. So that's a kind of a catch. And we can pass those two things in, and we can return our output image. Actually, let's give it a third variable. So we'll give it an image path. That's our input. Actually, you know what? We're not going to use this for saving. We're just going to use this for pixelating only, so we don't need to do that. So this looks good. We have our image path and our scale ratio. And let's now use some of this code that we wrote before to turn this into a function. So we're going to say the image is equal to cv2.imRead again, just like before, except this time we're going to pass in our image path. Okay? And we're not going to print the shape. We don't need to do that in this function. The purpose of this function is very simple. It's just to give us back our pixelated image. So then we need to create a low-res version of this like we did before. So we'll say image low-res equals, and we'll do our similar thing that we did before. You could copy this, but get some practice typing it if you're new. So we'll say resize, and we're going to pass in that image matrix. We're not going to use the exact size, but we're going to use the scale factor. So we'll say fx equals scale ratio, and fy equals the scale ratio, because we want to keep the ratio of the original image. We don't want to skew it, at least not with our intent for this function. Okay, so that gives us a new object, a matrix, a mat-like object, which contains all of that data, and then we will return that data. So the purpose of this function is not to print any information. It's not to display any information. It's simply to take our image and give us back a low resolution image. We could then use that down here like this now. So let me get rid of a lot of this code. And what we could say is image low res equals, and instead of calling CV2, now I'll just call my pixelate function. I'm going to pass it the path, which in my case was image / Mario dot, what was that, a JPG dot JPG. And I'll just use I can just use the default scale ratio, so I can just leave this empty, or I could provide a scale ratio. I have a choice now, and I could say 0.0, let's say 3 this time. If I want to make it a little bit blockier, and I can write it to the, now I have this low-res image stored here by just simply calling this one function, and I can do what I want. I could display it, I can write it. So I'm just going to run this now, and you can see I have my output.jpg here. Let's see, something wrong. Oh, output.png. I'm going to delete this, otherwise I'll keep making this mistake. So output.png, you can see it's a very small image now, even smaller than before. Still looks pretty cool though. From a distance, you can still make out Mario surprisingly well. And yeah, there we go. So we've wrapped it in a function. So that's the first best practice. Now the next thing that we're going to do, because again, treat this like an opportunity to kind of improve your programming in general. The next thing we want to do is we want to document our code. I mean, this is so simple and so obvious that you might think, why would I document this? But it's a really good habit to get into to start documenting your code. Now, the first way we can document this code is we can actually use a triple single quote, and this will create a multi-line string, and we can create a description of what this function is going to do. So what we can say here, for example, is takes an input image matrix and returns a scaled down pixelated low res image. Okay, simple one-liner of what this does. And the nice thing is now, in the future when we use this code, when we start documenting our code, you'll be able to refer back to this. You won't have to remember, well, what does Pixelate do? Does that change the colors? Does that... And you can simply now hover your mouse over, and just like any other built-in function, we actually get a lot of information now. You can see that we get takes an input matrix and returns scaled down image. So that tells somebody what this function does, and they could use this outside of this program. Now it's also nice is we want to provide a little bit more information. So we have, so we can say parameters and do a notation like this. And we could say image path, and we can say that this is a type string. And then what we can do is we can say what this is. So the path to the input image. Actually, this doesn't take an input image, does it? This takes an image file path and returns a scaled down pixelated low-res image. So that was actually the wrong description. So that's why even something as simple as this, it's good to start documenting and keeping all your ducks in a row. So this is the path to the input image, okay? And then we have scale ratio. And this is a float type object. So I'm making a note, so you can see the notation I'm doing here. This is going to give somebody a key, a little bit of a hint as to how to use this. Image path, string, the path to the input image. That's pretty self-explanatory. Somebody would understand what that means. Same thing here, scale ratio, float. So they know it's a float, and it can take a float, not just an integer. And we could say the scale to resize the image. And we can give an example. You could say 0.05 yields an image scaled to 5% of the original. Something like that. You can make this more or less terse depending on how you want to document your code. But now we have a nice explanation. So we have Pixelate. It takes an image path. It takes a scale ratio. You'll notice that I have a type here, so I can see that that's a float. So that's nice. And I know it returns a mat-like. So some of this is inferred. We can also see the parameters down here, and then it's also nice to say, oops, inside of our documentation, returns, and we can say scaled image, or we'll just say a np.array scaled image object, something like that. So now we can see very clearly what this does. Oops, under returns, I want to do this, sorry. So now I have a pretty nice little documentation for this code. I can see the parameters, I can see the returns. It's going to return an NP array, a NumPy array. I don't know if we talked about this in detail, but OpenCV stores image data in a NumPy array-like object, and it returns that scaled image as a NumPy array. Maybe a better way to say this would be scaled image as NumPy array, something like that. Okay. Now this seems like a lot of work, but it's absolutely worth it, guys. Highly recommend it. You can see now we have a very nice way to look at our documented code. Now there's actually something else that I recommend you start doing as well. Take this one last step, and then we're going to have a very well documented code. We can actually provide type hints to Python. So in Python, of course, as you know, we don't have to specify what type this is. We could pass in an integer, we could pass in anything. Python is a very loosey-goosey language, which is good in a lot of ways for speed and getting things done. It's also bad because it can be a source of a lot of bugs. That's why a lot of the more elite programmers, some people tend to look down on Python and when they compare it to other statically typed languages. But Python does have the opportunity to improve your code quality through the use of type hints. So to add a type hint, we're going to add a double colon here, and we'll provide the type of this object. So in this case, this is a string. And you can see that my IDE actually already inferred that this to be a float, but we can more specifically give it that information. So here it's a scale ratio of type float, and I'm setting a default value. So I've been very specific about what I expect that to be. This is extremely useful because as you start to write more and more complex code, guys, you're going to be confused what type of data can go in there. And a lot of times you'll put in the wrong type of data, let's say, but still get what seems to be like valid results. That happens all the time. As you know, in Python, for example, it's valid to say the number 0 plus 1, right? This is valid. Now, in a lot of other languages that are statically typed, that would not be valid code. We could not use the addition operator between a type integer and a type string. So Python gives us a lot more flexibility with how we write our code, but we have to be responsible and document it well. And then the last thing we want to document is, you can see this is already inferred that it's returning a mat-like. But what we can do is we can actually be very specific. I don't even know if I can do. Let's actually see. Does CV2 have a mat-like? I don't think so. So what I usually do is when I'm working with OpenCV and I know it's a NumPy array-like object, I will provide it with a explicit return type. So to provide the explicit return type or the expected return type, we use this type of operator here. It's a minus sign with a arrow. So it's kind of like an arrow. And then we provide the type. So if this was returning an integer, we could say, arrow integer if it was a float. But in our case, we want to, do we have NumPy? Oh, that's the problem. Okay, import. So we want to import NumPy as NP because we are going to want to use NumPy functions. We'll come back to NumPy in a minute, but I just want to make sure we have that in our code. So this is returning a NumPy array. So ND array is the data type. So it's an array in NumPy. So now if I put my mouse over Pixelate, you can see that everything that I put in here is very specific. So it's expecting a string and a float, and it's going to return an ND array from Python, from NumPy. Again, this is our detailed documentation here. So this is a great best practice to follow. Adding document to your code. What does it do? What are the inputs and outputs? And then providing type hints like these so that people know how to properly use your code and avoid a problem such as this. I'll give a quick example. We'll call this add, where I have A, B, and I return A plus B. So you can imagine if I had 0 and 1 here, my return would be the number 0 plus the number 1. That might be what somebody expects. But if I put in a 0 and a string, I'm going to get a totally different output. So by adding this information, that this expects an integer and this expects an integer, we can then make sure that our functions are being used properly. That's kind of a silly example, but I just want to make sure I drive that home. So this was a great first step for you guys to start documenting your code if you're just starting along your Python journey. So in the next video, now that we've created our first function here, we're going to start creating our color comparison functions now that we know the best way to create functions and document functions. So I'll see you in the next video.